Now the question is, if n integers are taken at random and they are multiplied together, show that the chances that last digit of the product is 1, 3, and it should be 7 also. 1, 3, 7 and 9 is 2 to the power n upon 5 to the power n. The chances of it being 2, 4, 6 and 8 is 4 to the power n minus 2 to the power n upon 5 to the power n. Its being 5 is 5 to the power n minus 4 to the power n upon 10 to the power n, and that of its being 0 is this value. Now we know that last digit on any number could be 1, 2, 3, 4, 5, 6, 7, 8, 9 or 0. Now we multiply any number with 2, 4, 6, 8 and 0. It will be an even number. We do not want that number to be even. And we multiply it with 5. Then it will either end with 0 or with 5. So that means we cannot choose 2, 4, 5, 6, 8 and 0. So the chances that last digit of the product is 1, 3, 7 and 9 if we choose the numbers whose last digits are 1, 3, 7 and 9. So that means this probability should be 4 by 10. Now it should be 4 by 10 for the second number, 4 by 10 for the third number, and it goes all the way up to 4 by 10 for all the n numbers. So this is nothing but this is 2 by 5 to the power n. So this first case when the last digit of the product is 1, 3, 7, 9 is 2 by 5 to the power n. Now the second one is chances of its being 2, 4, 6 or 8. Now if it is 2, 4, 6 or 8, then from these 10 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, it should not have 0. It should also not have 5, and it should have at least one of 2, 4, 6 or 8. So from these 8 numbers we can form 8 to the power n numbers, and from this we'll subtract all those cases in which none of 2, 4, 6 or 8 is chosen. So there will be 8 to the power n minus 4 to the power n divided by 10 to the power n. So this required probability will be 4 to the power n minus 2 to the power n upon 5 to the power n, and that's your second part. Now in the third part it says the probability of its being 5. Now it will be 5 when out of these 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. It should not have 0. It should not have any of these even numbers, and it must contain at least one 5. So total number that can be formed is 5 to the power n minus all those cases in which 5 is not included, 4 to the power n divided by 10 to the power n, and that's our third probability. And finally we have this where it says the probability of its being 0. Now basically all these 4 cases, they are mutually exclusive and exhaustive. So first we'll find sum of all these 3 probabilities. Now say it is P1. Now this is 2 by 5 to the power n, which is 4 to the power n. This one is 8 to the power n minus 4 to the power n, and this is 5 to the power n minus 4 to the power n upon 10 to the power n. Now here 4 to the power n we cancel. So the required probability is complement of this. So it will be 1 minus, and this is 8 to the power n plus 5 to the power n minus 4 to the power n upon 10 to the power n. So it will be this 10 to the power n minus 8 to the power n minus 5 to the power n plus 4 to the power n divided by 10 to the power n, and this is what we need to prove in this question.